Worksheet 14b, also single pressure vessels. A spherical pressure vessel has an outer diameter of 6 meters and an inner diameter of 5.8 meters. The vessel is made of stainless steel cold rolled. Verify that the single pressure vessel theory is valid for this problem, and also B, determine the maximum allowable internal pressure, which is P max, if a factor of safety is 3.5 with respect to the yield stress is desired for the design, and we give the hint for the geometry, which is the outer diameter minus the inner diameter equal to the 2 times the thickness of the sphere. So the first part is A. We want to verify if the theory of the single is valid. So if you recall, to be consider a thin, the inner radius over the t, which is the thickness, that ratio have to be greater or equal to 10, which means that the goal thickness is very small compared to the radius of the sphere or of the any tank to consider a single. So from that, we need to determine what is Ri and what is T, so we can get this part done. So Ri, as you can see, they give us the inner diameter, so we have 5.8 divided by 2, so which is 2.9 meter. And then we have T, the thickness, at the hint, D0 minus Di equal to T. So we can have that is the D0 minus Di over 2. So it will be 6 minus 5.8 divided by 2. So it will be 0.1 meter. So from that, we can that ratio, go back to that ratio, Ri over T equal to 2.9 divided by 0.1, which is equal to 29, and of course it's greater than 10, so we can say that it's okay. The theory is good, right? It's valid, so that we can continue. We apply the equation that we learned for this problem. And the next is the question asks is determine the maximum allowable internal pressure, which is the P in the equation. So for the apply the general equation, sigma actual less than sigma allowable, and sigma actual for the sphere, as you can see, that is the sigma sphere, and in this case sigma sphere equal to P I over 2T, and less than the allowable with respect to the question is yield stress, so it will be sigma yield over the factor of safety. And yielding yield stress for which material? Stainless steel cold roll, and this is about the SI unit. So you go to appendix B, but use the SI unit. You have appendix B for customary unit, and go down to the next page. You have SI units, and look for the stainless steel cold rolled, as you can see there, and look for the yield stress, yield strength and tensile. In here, as you can see, it equal to 520 megapascal. Everyone see that here? So go back to there. We can see from appendix B, that right down here, appendix B for stainless steel and cold rolled. Then we have sigma yield equal to 520 megapascal. So from that one here, we can plug in into this equation. Back here, the question is asked what is the maximum allowable internal pressure, which is P. So we can plug in P times Ri. We already find out that it's 2.9 meter. So everything have to be meter in here. to T is 0.1 meter, so plug in, less than or equal to 520 megapascal. Divide factor of safety, the question is 2.5 over there, and you can see, so 2.5. So from that we can have P less than or equal to 14.3 megapascal. So what does that mean? The P max, what is the maximum allowable internal pressure? So we can have P max 14.3 megapascal, and that should be the answer. Maximum internal pressure of this sphere, and we have that worksheet 14b done.